All right, so as we talk about graphing, just want to go over a few things with you. You're going to have a table of values, and on this sheet that I've given you, you have x and y. On your axis, please remember that this horizontal axis is the x, and this vertical axis is the y, right? That's always the way it is in math and in science. Sometimes you'll have different quantities, so they might not just say x and y. If you look at the back of your page real quick, they have something like kilograms as one of the quantities, and then height as another. So you might see x, y, you might see kilograms and height, you might see speed and force. There might be all sorts of different things that you're comparing. The big thing is when you're graphing in a coordinate plane like this is there'll be two quantities, and you're just trying to seek some kind of relationship between them. So you're trying to show how, as one changes, what happens to the other one. And that's what graphing is all about. It's just a way of displaying this sort of correlation or this sort of information. So on the front page here, we have a list of x values that look like this. So this is what's on your paper, and it's important to know that the first two numbers here, the x, y values, those are a pair. Okay? And we often call them an ordered pair. So this is actually a point on the graph, -3, -10. Okay? Now when you're graphing, and here are our coordinates to the right here, and you want to make sure that you're going to be able to fit all of the points on. So before I start plotting this point, -3, 10, I have to establish what my axis is going to look like and what the ratio and the scale of the axis is going to be. So let's take a look at all of the, first of all, y values. What's the range of y values? That is, what's the smallest y value you see here, and what's the largest y value? Smallest is -10. Very good. The largest is 9. Okay. So that means on my scale, I need to at least go from -10 on the bottom to +9 on the top. Now, if it's easier to go from -10 to +10, that might be a real good idea. So let's just see what we got here. Okay, so just made some adjustments here, but I don't know if you guys can see this, but I have grid paper on my on the screen there. You see that? The lines are really light for you to see, but this is what I have. Okay, so I have a line there, 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 and there. The important thing is that you evenly spread out your little tick marks there, and you have to choose an appropriate scale. So I need to go from at least -10 to +10. Okay? So, and I also want to use as much of the graph as possible. So don't put 10 here and -10 here is what I'm saying. You don't want to do that because then all of your points are going to be squished up in here, and we want to use this whole space, okay? So let's just take that off, and we know that we're not going to use 10 and -10 there, but we might want to try and have 10 or something close to 10 at the very top. So I have, on my particular graph here, I have 1, 2, 3, 4 spaces that I have top and bottom. So we might want to do, we could do 3s, right? If we do 3, 6, 9, 12, that's going to spread out the dots towards the top, and we could do 3, 6, 9, 12 here. On your graph, okay, what does yours look like? How many spaces does yours have? 12 or 13? Okay, so on your graph, okay, each let me try and make mine kind of like yours. Okay. So the big thing when you're drawing you're making your scale is that you use as much of the graph as possible. So this is what yours looks like. So I've labeled mine so it looks just like yours. Okay. So now let's go and label some points here. So -3, -10. Remember that the first coordinate or the first number here is always the x. The second is always the y. That's the way it always is. Okay. X, y. Draw these coordinates. So you go from the center. You go 1, 2, 3 units to the left, because that's what -3 represents. 3 units to the left, and then you go 10 units down. So we'll just follow this vertical line down to 10, and that's what your point should be. Okay? Okay, so on your graph, you have it labeled, and you have your point. And you can go ahead and you can do the other points as well. So -10, you go over to -10, and you go down to 6. So negative 10 down to negative 6. All right, and you can go ahead and put the rest of those points on there. Okay, so as you put these points down here, just take a look up here. I'm gonna point to one of my coordinates here, and I want you to tell me which one it is. I'm gonna label just a few of them. Okay, so this one right here. Which one is this one right here? Yeah, it goes 7 to the right, and then 4 up. So this is 7, 4. Now, I would like you to label yours as well. Okay, so you've got the point, and I want you to label it as well, just so you know. Okay, what about this one? What's this one way over here? This is, yes, negative 10, negative 6. Okay? So go ahead and label all of your points as well. And if you need help, you can look up here. I'll be doing the same thing. Okay, once you got your points all labeled, should look something like this. Okay? I'm going to teach you a few other things about graphing. Do you guys remember, or do you know, you guys are in, what are you guys, grade 11, you should know this. What are the quadrant numbers? What's this quadrant number right here? This is 1. Very good. I'll put that in green. Okay, so that's quadrant 1. And yeah, we kind of do it Roman numerals. That's why it looks like that, not just our numerals, but Roman numerals. That's the way they're typically expressed. So this is 1. Which one is this? 4. Ah, kind of fooled you there. Okay. What's this one? This is 2, and this is 3. 4 is already taken. Yeah. We don't have 2 quadrants labeled 4, but that's okay. So yes, it goes counterclockwise. So 1, 2, 3, 4. Okay, quadrants. Now, what do you notice about the points in quadrant 1? I'm thinking of I'm making an observation myself there. Which is the one that? What's the observation I'm making? What do you think it is? Yes, both numbers in the coordinates in quadrant 1 are positive. So this is positive. You don't have to write this down, but I'm just showing you. See, these are all positive here? Positive, positive. So in coordinate 1, I'm going to get you to draw this down. All the x values are positive, and all the y values are positive. Because we move from the center, we move to the right in the x direction, that's positive, and then up in the y direction, and that's positive. So what about here? We don't have any points in quadrant 2, but what are the signs? What would the signs be for all of the points in quadrant 2? Negative, positive. Very good. Negative, positive. All right, and then quadrant 3, they are negative, negative, yeah. Every time I do this, it kind of looks like a face with the eyes and the nose. Anyways, okay, and this one would be then positive and negative. Good. That's very important for you guys to realize that and to recognize that observation. It's really, really important. So I want to talk to you about this line of best fit. Now, when we're graphing, a lot of times, I'm talking please. When we're graphing, a lot of times we will have points, okay, in the x and y points that will form some sort of relationship. Okay, that means that there's some sort of pattern that's predictable. And when I start filling in these points, you might be able to see that there's some predictability here, right? As more points come online, you're kind of seeing, hey, I'm seeing a definite pattern here. And that pattern may look something like, this. Now, notice I'm not going through all the points necessarily. But what I'm doing is I'm drawing some sort of smooth curve or straight line that would represent a general pattern for the relationship of these points. Okay. Now I could do that, but I also could do a straight line as well. Now the straight line, as you'll notice, probably won't be quite as good as the curved line. But let's say I do something like this. Now that line would be a straight line of best fit for those points. It's not as good as that curve was, but what you're going to be asked to do in your graphing activities and with your data is to draw usually a straight line of best fit. And what this does, it says, okay, generally as X, increases, Y increases at this rate, and it would be the slope of this line would be the rate at which one changes with the other. And so if we go back to the notes here, what could we say for notes? Well, a line of best fit, okay? It is either a straight line or a curve that best approximates the general relationship between the variables. And an approximate general relationship is really handy when we're just trying to see overall patterns. Okay. For example, let's say that that this was cost, okay, or revenue. Let's say that the Y is revenue, okay, and the X is the employees, I guess. Employees. Now, if I did something like this, all right, I wouldn't probably be able to have 0 be right here, okay? It'd probably be something like this. Here would be my y-axis, okay? Okay. Now, if this was the line, and revenue was y, okay, and I had, let's say, 1 or 2 or 3 or 4 or 5 employees, what this means is that I am basically going to be losing money if I only have between 1 and 5 employees. Okay? So here's 5 employees. But what this data is saying is that if I have more than 5, or if it was a little more accurate, it would be something like almost 6, right? But we would need at least 6 employees in order to start making money, if this was positive money that we would be making, right? Revenue. So here we're losing money down here with these number of employees, but we're making money if I employ some more people. Okay, for various reasons. So this black line right here is really handy to make a quick look and say, hey, listen, 5 employees, between 5 and 6 employees, that's my break-even point. I need to employ at least 5 people to keep everything going in my shop so that I can break even. If I can employ a few more, and we can make more things and sell more things, I'm going to start to make money. Okay? So if you didn't have this line, this black line, right? I don't know if I can erase it with this or not. Maybe it won't let me. But anyways, if this black line wasn't there, these dots would look a little bit confusing maybe. It would be like, okay, well, it looks like maybe somewhere around here. I don't know. And that's just an example I pulled from the top of my head, okay? But it's a curve or a line that best approximates a general relationship between the variables. Now, what are some good rules to keep in mind when we're drawing a line of best fit? Okay, well, let's talk about that. Okay, so a line of best fit, and I'm just going to abbreviate it a LOBF. A line of best fit, and you can do the same if you don't want to write it. A line of best fit usually has and this is what I'm going to put, the same number of points above the line as below the line. So that's a good gauge to see if you're going through all of the points. Now I guess I don't really know if my line of best fit follows that exactly, but let's just see. Okay, I thought this was a pretty decent line of best fit given given my data. And so let's see, I've got 1, 2, 3, 4, 4 above, 5, 6 above. Okay, and how many do I have below? 1, 2, 3, 4, 5, 6, 7, 8. That's pretty close. Pretty close. This one probably could be counted above, so I have 7 above and 8 below. So that's pretty good. You see how that works? Okay, if the line was, horizontal like this, that wouldn't be so good. You want to kind of approximate the general relationship there. All right, so I'll draw that. I would want to mention one more